Understanding the nature of the interstellar object 3I Atlas is not just a scientific curiosity, it could potentially reshape our understanding of what lies beyond our solar system. The key to differentiating a spacecraft from a natural celestial body, like a comet, lies in the measurement of non-gravitational acceleration. Comets, which are essentially icy rocks, are propelled by the loss of mass as they approach the Sun. This mass loss manifests as a plume of gas and dust that envelops the comet's nucleus. By analyzing the rate at which this mass is lost and the speed at which gas and dust are ejected, scientists can determine the momentum change over time, which is referred to as non-gravitational force acting on the comet's nucleus. This force, driven by the evaporation of volatile materials on the sunlit side of the comet, pushes the nucleus away from the Sun. However, as the comet travels farther from the Sun, typically several times the distance between the Earth and the Sun, its surface cools, reducing the release of volatile ices and dust, and thus diminishing its activity. In contrast, a technological object, such as a spacecraft, can maneuver independently of solar influence. It can be directed toward the Sun or any other celestial body, exhibiting non-gravitational acceleration that can vary in both magnitude and direction. This ability to perform non-gravitational maneuvers could elevate an interstellar object's classification on the load scale, a system that ranks objects from 0, indicating a natural comet, to 10, which signifies an unmistakably artificial construct. Given this framework, it becomes crucial to measure the acceleration of 3I Atlas as it traverses the solar system. Observing any deviations from its predicted gravitational path could lead to significant implications, including public concern over the possibility of extraterrestrial technology. If 3I Atlas deviates from its expected trajectory after its closest approach to the Sun on October 29, 2025, it could trigger widespread speculation and anxiety, potentially impacting financial markets. So, what would be the expected non-gravitational acceleration if 3I Atlas is indeed a natural comet? Recent observations from the Hubble Space Telescope have revealed a glow in front of 3I Atlas, but notably, there is no bright tail of gas and dust trailing behind it, which is a common feature of comets. Additionally, spectroscopic analyses have found no signs of molecular or atomic gas accompanying this glow. This leads to a plausible interpretation. 3I Atlas may be a dust-rich comet that primarily ejects large dust particles, which are not significantly affected by solar radiation pressure or solar wind due to their relatively small surface-to-mass ratio. Therefore, we can estimate the expected non-gravitational acceleration based on the observed dust plume ahead of the object. A thorough examination of the glow preceding 3I Atlas suggests a mass loss rate of up to 60 kilograms per second for dust particles around 100 microns in size, with an ejection speed of approximately 2 meters per second, directed toward the Sun. For smaller 1-micron particles, the mass loss rate drops to 6 kilograms per second, with an ejection speed of 20 meters per second. Interestingly, the non-gravitational force acting on 3I Atlas remains consistent across these scenarios, as it is calculated by multiplying the mass loss rate by the ejection speed, making the size of the dust particles irrelevant to the overall force. The brightness distribution of the glow has also provided insights into the size of the nucleus of 3I Atlas, estimated to be between 0.32 and 5.6 kilometers in diameter. This size range suggests a nucleus mass between 30 billion and 200 trillion kilograms. When we apply the calculated non-gravitational force to this mass, we find that the non-gravitational acceleration falls between 3 times 10 to the negative 14 and 2 times 10 to the negative 10 AU per day squared, where AU represents the distance from the Earth to the Sun. In terms of more familiar units, this translates to values between 6 times 10 to the negative 11 and 4 times 10 to the negative 7 centimeters per second squared directed away from the Sun. For context, the first interstellar object, 1I Oumuamua, exhibited a non-gravitational acceleration of 1.4 times 10 to the power of negative AU per day squared on October 25, 2017, which is equivalent to 2.7 times 10 to the power of 4 centimeters per second squared. This acceleration is significantly greater than what is expected for 3I Atlas by factors ranging from 1,000 to 10 million. If 1I Oumuamua were a typical comet, it would have needed to lose about 10% of its mass during its close approach to the Sun. However, despite its substantial non-gravitational acceleration, 1I Oumuamua did not exhibit any signs of cometary evaporation, presenting a major anomaly regarding its nature. If 3I Atlas is indeed a natural comet, we might expect its outgassing to increase as it nears the Sun. Measuring the anticipated non-gravitational acceleration resulting from its cometary activity would help confirm its natural origins. A study I co-authored with my student, Sriram Alango, prior to the discovery of 3I Atlas, demonstrated that data from the Webb telescope, combined with observations from Earth-based telescopes, could accurately track the trajectory of an interstellar object using parallax techniques. The Webb telescope's position at the L2 Lagrange point, 1.5 million kilometers from Earth, allows for unprecedented precision in these measurements. A significant deviation in the measured non-gravitational acceleration from the expected cometary range could imply that 3I Atlas is being propelled by technological means. At this point, we cannot definitively determine whether 3I Atlas is a natural dust-rich comet on an unusual trajectory or a technological object following a path that appears to be intentionally aligned with the ecliptic plane of the planets in our solar system. What we do know is that 3I Atlas has a rare alignment, only a 0.2% probability of its retrograde path with the ecliptic plane within 5 degrees, and its timing is perfectly aligned for a close encounter with Mars, Venus, and Jupiter, with a probability of just 0.0005%. Such coincidences could suggest a mothership releasing mini-probes that would reach these planets as they enter the orbits of the probes, taking advantage of the mothership's retrograde motion. However, as 3I Atlas will be obscured by the Sun, this approach is akin to the Video Assistant Referee (VAR) protocol used by FIFA to determine the validity of goals in soccer. Decisions are made based on recorded data rather than the opinions of players or officials. History has shown us that scientific truths, such as the Earth's orbit around the Sun, have often faced skepticism, as exemplified by Galileo Galilei's house arrest for advocating this view. Ultimately, whether 3I Atlas is of natural or technological origin will be determined by empirical evidence, not popular opinion.